here I want to illustrate something else. So here you have the natural logarithm, right? And here you no, the natural exponential function, and here you have the natural logarithm. And then I have some other exponential function and some other corresponding logarithm. Agree? Now, it doesn't seem as if they have any sort of natural relation, but in fact they do. So it turns out that if you take this x-axis and instead of having 1, 2, 3, and so on, I have a fixed number of 1 over ln a. So see what happens now. I change my scale on the x-axis, right? Agree? But you also see that some things are fixed, right? I mean, at least visually, you can see that that these two functions stay at the same place. In fact, I think I have mislabeled these two and these two. Anyway, what I'm trying to illustrate here is that you can find a to the power x by just knowing e and ln of a. So taking a to the power x is the same as taking e to the power x times ln a. In other words, any exponential functions can be expressed in terms of the natural logarithm of the base number and e of x. And what you see here is that basically you're just multiplying the x by some constant. So if you divide by this constant, you're basically just scaling what could think of as the x-axis. Now one can do the same thing for the y-axis. Here you can see that I change my y-axis and the logarithm stays, right? So why is that? It's because log a of x equals log x over log a. In other words, if you know log a, ln of a and ln of x, you can find ln of a or log a of x by just dividing these two numbers. In other words, what does this mean? It means that any logarithm is just a scaling in the y-axis of the natural logarithm for any positive x, of course. And the proof is just using what we know of about the logarithm. So log ax equals y. That's just a relation between x and y. If this is true, then this is also true. Why is that? Well, it's true because we know that we can take a to this power and get to this power and get x, but it's also the same as a to the power y, which is then also the same as e ln a y, because of what we had here, right? We could also prove that by just using the properties. But if x is equal to this, then if we take the logarithm, the natural logarithm on both sides, we get ln x equals ln a times y, because taking logarithm of this and of this. Here on this side, we just get ln x. On this side, we get the exponent down, right? Because ln and e are e to some power is each other's inverses. And having this, we just divide by y. And the proof here is even simpler. We just say, well, a to the power x is just e to the power ln a. Why is that? Well, e to the power ln a is just a different way of writing a to the power x. And then we know by the laws of exponents, that having some number in some exponents to everything to a different exponent is just multiplying the exponents, so e to the power x ln a.